Hey, what's up everybody? I'd like to welcome you to another audio programming tutorial for beginners. And today we're going to look at FM, AM, and RM synthesis. So we're just going to get into some more synthesis methods, how we can create some more interesting sounds than a sine wave. Now what I'm going to give you is a very brief overview of these waveforms and how you can kind of implement them in your programming. And I could go a lot more in depth with these synthesis techniques, and we could start talking about sidebands and what frequency is it producing and why is it producing this frequency. But I don't want to get into the weeds too much with you at this point because this is supposed to be a beginner's tutorial. And I just really want to try to get things moving and, you know, get us producing cool sounds. Okay, and then later on we can come back and we can start getting more in depth and talking about you know, more of the theory and why it's making the sound that it is. So these synthesis techniques that we're going to discuss today, they aren't the only synthesis techniques there are out there. I mean, you have like additive synthesis. Well, any complex waveform is a form of additive synthesis because it's a sum of sine waves that are being added together at various magnitudes, phases, and frequencies. And then you have stuff like cross synthesis, but we aren't going to get into that today. So we're going to talk first about amplitude modulation and ring modulation synthesis. They are quite similar, and they work pretty much the same way. It's quite easy to get them confused. But they do produce a slightly different effect, and I'm going to show you how we can implement that here. Okay, so let's start off with amplitude modulation. And amplitude modulation is exactly what it says it is. It is it's modulating the amplitude of your waveform. Okay, so if we just look at our patch here, and we just kind of recap here. What I like to do is I like to think of this in terms of numbers. That really helps me kind of visualize what's going on. So just to recap, we have a cycle object that's oscillating at 440 times per second, so it's 440 hertz. This is a sine wave. It's producing values between +1 and -1, okay? We multiplied it by a trigger that is either a value of 0 or 1. Okay, so these values that are coming out of this sine wave oscillator are going in, and they're being multiplied by either a value of 0. So if they were multiplied by a value of 0, then they would all be 0, which means no signal gets played. Okay, and if they're multiplied by a value of 1, then the outgoing result is the same thing that went in. Okay, now I said that I couldn't remember how to find out what the values are that are actually coming out of the sine wave between -1 and +1, and I finally remembered. It's actually the number. It's called the number tilde object. Okay, so if I just do that, you get this little box here. So let me just go back there. I did that a little bit fast. So once again, it's N for a new object, and we're just going to type number, and it's not just the regular number. There's the number tilde object. Okay, anything with a tilde after it means that it's a signal rate. It's a signal rate object, which means that it's an object that's actually generating 44,100 times a second. Okay, so when I attached that to the outgoing to the outlet of the sine wave, now you can see that it's producing those values between -1 and +1 that we have talked about many times. Okay, and then if I just click the toggle here, when I press the toggle means when it's on, it's producing a value of 1. So you could just picture this being the number 1 that's going in here, and when it's off, of course, it's 0. So that's how we're hearing the sine wave that we're hearing. Okay, and then I could just change that frequency if I want. Okay, and that's what we had last week. Okay, So the first thing that we're going to do is we're going to talk about amplitude modulation. Okay, so far we have a value here that's either 0 or 1. But what if it's a value between that's between 0 and 1, not quite 0, not quite 1? Okay, how would that affect the wave itself? Well, let's find out. Okay, so what we'll do is we'll just create another cycle object. I hope I get all this right the first time around. And we'll do we'll just create it at 440 hertz. Once again, okay, and I'll just press I to create a integer box. Okay, just going a little bit slower for people that may be just working with Max MSP for the first time. Okay. Okay, so with amplitude modulation, the main difference between amplitude modulation and ring modulation is that amplitude modulation is generating values between 0 and 1. Okay, so if we look at our toggle, the toggle is either a 0 or a 1, and what we're going to do is we're going to create a wave that's oscillating 440 times per second, but instead of going between -1 and 1, we're going to make it go between values of 0 and 1, okay? And that's what we call a unipolar signal, okay, just for anybody that doesn't know. Okay, so the way that we're going to do this is with a little bit of math. So if I just press N for new object again, okay. So what we can do is we can multiply this signal times a half, okay, times 0.5. Okay. Now, one thing to note here is that I'm using the multiply tilde object. Once again, anything that you have a tilde after, that's a signal rate. That's a signal rate object, which means that it's going 44,100 times a second. Okay, and that you need to work with other signal rate objects in order to connect those. Okay, so what I'm going to do is I'm just taking these values. I'm going to multiply them by a half, okay? And then what I'm going to do is I'm going to take it and I'm going to add a half, okay? 0.5, okay? And then, okay, so let's say that this value, let me open a comment box. Let's say that we had a value of -1, right? Which would be the lowest value that we could have coming out of this oscillator that's going between +1 and -1, right? If I multiply that by 0.5, okay, then the largest value that could come out of this oscillator would be 0.5, okay? So let me just put a 0.5 there, okay? Or negative 0.5. Sorry, my bad. Now, if I have negative 0.5, which is the smallest value that would be able to come out of my oscillator at this point, and then I took the result and I added another 0.5 to it, then my lowest value would be 0. Okay, and that's what we've done here. Okay, we've taken all of the results that are coming out of this, we've multiplied it by a half. Okay, so same thing with the largest value. Largest value would be 1, multiply that by a half, that would be a half, and then we add a half, which would make it 1 again. Okay, so it's just a little bit of math trickery. This is one of the things that I'm not like, one of the reasons why I'm not the best with Max MSP. It's a lot of like kind of workarounds to get this thing to work sometimes, but this is the way to do it. Okay, so that's how we're getting values between -1 and 1. Okay, I feel like I need to demonstrate this for you just to show you, in numbers that's what's happening here. Okay, so let me just produce 2 number objects. Okay, they're number tilde objects because we're at signal rate once again. Okay, and if you look at this value, you can see this value is going into the negative. Okay, it's going between -1 and 1. Then if you look at your value here, it's going between 0 and 1. Okay? So what we're going to do is we're going to kind of move this actually. I'm going to move this up. Okay, and I'll move this up as well. And what I'll do is I'll actually add another times tilde object. Okay. And as I said before, it's good to instantiate it with a with an initial value. Okay, so just to run you down kind of what I've done here, just in case you're not following me. So we have our sine wave that's going between at 440 hertz between values of -1 and 1, and it's going into this multiplication object. Okay, now the way that we had it before, we had the values going being multiplied by either 0 or 1. Okay, that was just turning the wave on or off. But now what we're going to do is we're going to have this value multiplied by values between 0 and 1. Okay, rather than just 0 or just 1. Okay, and this is amplitude modulation. Okay, now I've put it into another multiplication object. Okay, and that is turning the signal on or off. Okay. So I don't want to repeat that again because it'll get too redundant. But so this turns the wave on or off, and listen to the timbre of the wave. Okay. If I just put it to 0, then let me turn it up a little bit. Okay, we're just getting the normal wave. Okay. I'm just moving it up and down the frequency spectrum. Now, what happens if I change this to 1? Okay, it's distorting because because this value is bigger than 1, which makes it distort. But you can hear that it's actually modulating the amplitude 1 time a second. Okay, and if I moved it to 2, that's 2 times a second. Okay, and then I can just keep on going. And then eventually, you start to get this interesting kind of timbre to it. Okay, you can hear that there are some other sidebands in there. Okay, it's like aliens from outer space. Okay, so that is amplitude modulation. Okay, I'll just put this AM synthesis, amplitude modulation. Okay, and let me just I'm just going to straighten out. I'm going to attempt to put all of these in one patch here. So I'm just going to go ahead and delete this. And then if you right click on the chord itself and hit route patch chords, then it makes it nice and neat like that. Okay, so now what we're going to do is we're going to do the same thing. Okay, so I've just copied our sine wave oscillator and our frequency box. Okay, and now what I'm going to do is I'm going to change this back to 0. Okay. And now this is generating values between -1 and 1 rather than between 1 and 0. Okay, and let's see how that sounds in comparison. Okay, turn the wave on. Okay, so it's not doing anything at the moment. Okay, so now let me just put that. If I just move that up the scale, you can hear that the sounds pretty much the same, right? Right? Sounds like a UFO. But if I put them side by side, right, you'll hear and if we do a comparison, I could put like a selector object in here and all that, but that's just going to take time, so I'm just going to do it manually. So listen to how that sounds for a second. Okay, now listen to how this one sounds. Okay, so that's amplitude modulation there. Okay, now this is ring modulation. Okay, hear how it sounds very similar but not quite the same. Okay, now ring modulation, I'm just going to put a comment here. Synthesis. Okay, I'm just going to move this over. Move this one over rather. Okay. So just to review, okay, like I said, I'm not going to get too far into, well, why is the one sounding different than the other, and so on and so forth. Okay, the important thing to know at this point is that ring modulation, or RM synthesis, is you're using a modulating wave to modulate the amplitude between values of -1 and 1, whereas AM synthesis, amplitude modulation, you're modulating those values between 0 and 1. Okay, so if you've ever heard of a LFO, low frequency oscillator, okay, that is that's a method of remodulation. Okay, so if your modulator is 20 hertz or below, then that's considered what's called a low frequency oscillator. Okay, because 20 hertz is below the range of hearing. Okay, and then if you move up, then obviously you start to get these timbres and stuff. Okay, cool. So that is AM and RM synthesis. Okay, so let's talk about my favorite now, which is frequency modulation. Okay, so with frequency modulation, what we do is that you have your carrier wave, okay, as we have with these other examples, which is this object here, the sine wave oscillating at currently 293 hertz. Okay, and then what's happening is that the frequency, okay, this 293 is going to actually be modulated by a wave. Okay, we're going to use another wave, a modulating wave, to actually change the frequency that goes into this cycle object here. Okay, so let's talk a little bit about how we're going to do that. I'm just going to move this over a little bit. Okay, so let's create our wave first. Okay, so we'll just do another cycle at 440. Okay, we're just going to create another integer box by pressing I, and we're just going to patch that into the cycle object. Okay, now what we're going to do is we're going to create a multiplication object. Okay, and it's good to instantiate the values. I'm just going to instantiate it to 1 now. Okay, and what we need to do, so this is called this frequency. Okay, oh, actually, let me not get into that at the moment. Okay, what we're going to do is we're going to produce what's called a float box. Okay, just by pressing F. Okay, it's just a number box. Okay, I don't think I went over this, but let me just do this for people that don't know. The difference between a float and an integer. Okay, for now, all you need to remember is an integer are whole number values. Okay, so -1, 10, 100, 1,000, 1,000,000, -1,000,000. Okay, but 1.65, 2.94, so on and so forth, those are floating point values, okay, values that aren't whole numbers, okay. You can have a whole number value as a float as well, okay, but when people say a float, normally they're talking about a decimal point number, okay. So that's why you have that little point there for floating point value and none there for our integer, okay. So going back to what we were discussing, so we've created another oscillator here, okay. We've got a frequency that's going in here, okay. Once again, this is a sine wave object, cycle object, that's going at 440 hertz, okay. Then we have what's going to be called our modulation depth, okay. So this is how much our frequency, our carrier, not carrier wave, our modulating wave is going to affect our carrier frequency, okay. So what I'm going to do is I'm going to actually go like this, okay, so you don't get confused. So this is our frequency of our carrier wave. Now I'm going to use another type of object, okay. It's called sig, okay, sig tilde, okay. Now the reason that I need to do this, okay, is because I have this cycle object, and remember what I was saying about signal rate objects, okay, that have this tilde at the end, okay. When you're working with a an object that has a tilde at the end, you have to use other tilde objects with it, okay, or else it's not going to work. If I just take this 293 and I just try to plug it in here and try to do something between those two, that's not going to work, okay. So what I'm going to do now is I'm going to do a plus tilde object, okay. Once again, we're going to instantiate the value, okay. I'm just going to put it at 1, okay. And now what I can do is I can work with these values, okay. So you have 293. All that's doing is that's just outputting 293, but at signal rate 44,100 times a second, okay. And I'm going to add it with this little wave here. I hope I did this right. Okay. So now we're just going to turn it on. Okay, we don't hear anything. Okay, cool. All right, so now we have our wave, just a regular sine wave. Okay, 270 hertz. Okay, now what we're going to do is I'm just going to set a frequency here. Okay, you don't hear anything yet because I haven't actually done anything with the depth. Okay, so let's just set it at 270 hertz, just the same as our carrier frequency. Okay, so now we're just going to start increasing the value here and see what happens. Okay, I hope I did this right. Okay, so now you're starting to hear like this interesting kind of timbre happening. And the more I increase it, the more that it's producing that really interesting kind of harmonic, okay? Okay, and see what happens when I mess with the with my carrier frequency. Start to get these really crazy sounds. Okay, now watch what happens if I turn down the frequency of our modulating modulating wave. Okay, let's see what happens when we turn it way down. Okay, see how you're getting these crazy like kind of sounds? All right. And now watch if I turn the modulation depth up, but I have the frequency down. Now you're getting this really... Now listen to that. Okay. And if I just do that more... Yeah. So the important thing to remember... So if I have this at 1 hertz, is it 1 hertz? So 1 time a second, you can hear that's modulating the frequency of my 242 hertz. Let me see if I can actually get the actual value that's happening there. I think this might just produce the values between. Let's see. Oh, okay. So that's showing actually what our frequency actually is at these various points. Okay. So if I turn the depth all the way down, you'll see that it should remain at 270 or 242 rather. Okay. And then watch what happens if I turn the depth up. See how it's oscillating back and forth. How it's using the modulating waveform to actually change the frequency of our sine oscillator. Okay, and then if I increase that again, okay, so it's just increasing that frequency, the frequency of the oscillations faster of the frequency. Okay, and then that's how you're getting those really interesting timbres. Okay. So I hope that was educational for you. So this is these are some of the commonly used synthesis techniques, and that's where we're going to end here. I think what we're going to do for next tutorial is we're going to actually start taking this oscillator that we've built, and we're going to start talking a little bit about filtering, just a little introduction to filtering and subtractive synthesis. Okay, so I hope you enjoyed this tutorial. Be sure to like and subscribe, all that business, and I will see you next time.